This video is about slopes of parallel and perpendicular lines. So, what does it mean for two lines to be parallel? Our geometric definition is two lines in the same plane that never intersect. But how can we recognize them a little bit more readily here? So we have for slopes of parallel lines, if two non-vertical lines are parallel, then their slopes are equal, which makes sense. Slope tells you direction that the line moves. If they're both moving in the same direction at the same rate of change, then their slopes are equal and the lines have to be parallel. Notice also it says if the slopes of two distinct non-vertical lines are equal, then the lines are parallel. What's that saying? That's basically just saying the converse of what number one was. And then it says any two vertical lines and any two horizontal lines are parallel to each other. So the first question here says, are these two lines parallel? Explain. All right, so the first thing I want to do is I want to find the slope of L1. Now to do that, I'm just going to go ahead and count. Let's see. I'm going to go from here down 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3 to the right. So that would be negative 9 over 3, which I know simplifies to negative 3 over 1. All right. Now I'm going to find the slope of L2. All right. And if I look at L2, I'm going to go down 1, 2, 3, 4, 5, 6, 7, and 2 to the right. So down 7, 2 to the right. And if I compare these two slopes, are they the same? No. So these lines are not parallel, and my reason would be slopes not equal. All right? So let's take this a step further. What if they want us to write the equation of a line that is parallel to this given line and contains this point? Well, we learned in the past we have this formula, y minus y1 equals m times x minus x1, or point slope form. So I know that I'm given here a slope of negative 3. But what I need is the parallel slope, the slope of the line that will be parallel to this given line. I know my rules for parallel say slopes are going to be equal. So the parallel slope is also negative 3. If I use these two pieces of data, I can write the equation y minus 8 equals negative 3 times x minus negative 1, which would be x plus 1. And then distribute negative 3x minus 3 and move the 8, and I get y equals negative 3x plus 5. All right? Now what about perpendicular lines? Well, slopes of perpendicular lines, how we know they're perpendicular is if the product of their slopes is negative 1. All right? If the product of their slopes is negative 1, then the lines are perpendicular. An easier way to remember this too, guys, is that the slopes are what are known as opposite reciprocals. Opposite means if the given slope is positive, then the perpendicular slope would be negative, and vice versa. Reciprocals mean take a fraction and flip it over. So for example, the reciprocal of 5/9 would be 9/5. All right. The reciprocal of 4 would be 1/4. The reciprocal of 1/5 would be 5/1, or just 5. They also conclude that any horizontal and any vertical line together are always going to be perpendicular. All right, so in other words, what this is saying is if you have a horizontal line, that means slope is 0. If you have a vertical line, that means the slope is undefined. I'll just abbreviate it. The slope of 0 and the slope that is undefined indicate that we have perpendiculars. All right, so let's take a look at this first one. L1 and L2, we got to find their slopes to determine if they are perpendicular. All right, So the slope of L1, again, I'm going to count here. So let's see, we're going to go down 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4 to the right. So that was down 6, 4 to the right. And I'm going to go ahead and simplify it to negative 3 over 2. Now let's find the slope of L2. The slope of L2, I'm going to again count. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I went up 6 and 9 to the right, which simplifies to 2/3. If I were to take the slope of L1 and multiply it with the slope of L2, I get negative 6 over 6 or negative 1. That is confirming to me that L1 is perpendicular to L2. And it says explain. All this work is my explanation. Okie dokie. So now let's take a look at another example similar to the one we just did. Okay, I don't know why that's in the middle there. Okay, so, but now they don't give me a picture, they give me points. So let's see. The slope of L3 would be the change in y over the change in x. So I'm going to go 7 minus negative 1 over 2 minus 3, which would be 7 plus 1 or 8 over negative 1. So that's negative 8. Okay, the slope of L4, I'm going to use C and D, so let's go 6 minus 7 over negative 2 minus 8, which would be negative 1 over negative 10, or 1/10. If I were to take negative 8 over 1 and multiply it times 1 over 10, this does not equal negative 1, so lines are not perpendicular. Okay, what about writing the equation of a perpendicular? All right, so I know to write the equation of a line, I need a point and the slope. The slope that I need now is a perpendicular slope to this given line. So if this given line has a slope of 1/5, the perpendicular slope would be negative 5 over 1, or just negative 5. So I'm going to use that point in the slope. Let's see, I've got y minus negative 4, which would be y plus 4, equals negative 5 times x minus 15. Distribute y plus 4 is negative 5x plus 75. Subtract the 4, I get y is equal to negative 5x plus 71. All right, and the final example here, what's the equation of the line perpendicular? There's that key word again. I know this line has a slope of negative 3. The perpendicular slope then would be negative becomes positive, flip 3 over 1 to 1 over 3. I then write y minus 7 equals 1/3 times x minus negative 3, which would be plus 3. Distribute y minus 7 equals 1/3 x plus 1/3 times 3 would be 1. Add 7, I get y equals 1/3 x plus 8. Hope this helps. Good luck.